Okay. Hello. So, hi everyone. So, good afternoon all. So, first of all, let me know whether audio and video everything clear. So, Ankit Kumar, good afternoon, Ankit Kumar. So, first of all, let me know whether audio and video everything clear. So, if it is not clear, please comment in chat box. Okay. Yeah. Right. So, I hope everything is clear here. Okay. So, we are dealing with the subject electromagnetics, and the topic that we are dealing is electrostatic potential energy and electrostatic potential. Okay, electrostatic potential energy and electrostatic potential. So, this is the topic we are dealing with, right? Okay. So, in the previous session, we have seen that whenever they have given some electric field distribution, how to determine its corresponding potential distribution. So, I have told you a method to determine the potential distribution. So, whenever they will give electric field distribution. So, what is that method here? So, we know that E is equal to what? E is equal to minus gradient of V. So, E bar is equal to minus gradient of V. So, this is nothing but Ex Ax cap, Ey Ay cap plus Ez Az cap is equal to what? Is equal to, I can write it as minus of dou V by dou X Ax cap plus dou V by dou Y Ay cap plus dou V by dou Z Az cap, right? Okay. Now, if you equate x components on both sides, you are going to get dou V by dou X, dou V by minus dou V by dou X is equal to Ex. So, from here I have told that V is equal to what? Minus of integral Ex dx. Now, here the integration constants are nothing but what? Integration constant is nothing but f of y comma z. So, what do you mean by integration constant here? What do you mean by integration constant? So, integration constant means it must be independent of integration variable. Here the integration variable is nothing but x. So, here f of y comma z is independent of what? Is independent of x. So, we can treat f of y comma z as what? As integration constant, right? Next, I have put here plus c here. So, I have told that this c represents what? This c represents some reference potential. I have told that the potential is always defined with respect to some reference point. So, in general, we are going to treat that reference point as infinity unless they have not specified anything. Understood? So, at infinity, what is the potential here? In general, at infinity, the potential is going to be 0. So, we are going to replace this c with what? C with 0. So, in general, we are going to consider the reference point such that the potential at that point will be equal to what? Will be equal to 0. So, in generally, at infinity distance, the potential will be equal to 0. Understood? Okay. So, this integration constant will represent what? Will represent the reference potential, and always we will consider the reference potential as what here? Potential as 0. So, that is why we will replace C with what? C with 0, right? Okay. Alok Kumar, good afternoon, Alok Kumar. Okay. So, I think Alok Kumar, you are absent yesterday, okay, but I hope you have revised the previous lecture, I hope so, right? Okay. Okay. So, in the same manner, I can write it as what? If you equate the y components on both sides, I can write V is equal to minus of integral Ey dy plus f of x comma z. And similarly, I can write V is equal to minus of integral Ez dz plus f of what? Plus f of x comma y. Okay. So, if you observe here, whether you consider this equation, let us say this is 1, or you consider this equation, so this is equation 2, so this is equation 3, So, you can consider any of these equations here, if you consider any of these equations. Okay. So, all the equations must give you what? Must give you the same potential function or not? yes or no? So here V is equal to this one, and here V is equal to this one, and here V is equal to this one. So this V represents what? The wherever you are writing V, so it represents the same V. Here also V same, here also V same, here also V must be same. So whatever the expression you are getting from equation 1, the same expression you have to get in equation 2 also. The same expression of potential you have to get for equation 3 also. So that means in order to determine the potential function, okay, you can use any of these three equations. So if you use this first equation here, suppose if you are using this first equation, then V is equal to what? V is equal to minus of integral Ex dx plus f of what? Plus f of y comma z. Here the only one unknown is nothing but what? Here the unknown is nothing but f of y comma z. So in order to determine this f of y comma z here, they are going to give you what? Field distribution. So that means you know this Ex value, they are going to give that, understood? So you can determine this term here, you can evaluate this term because they are going to give you the electric field, understood? But you don't know this one, f of y comma z. So I have told you how to determine f of y comma z. So how to determine here? How to determine f of y comma z? How to determine f of y comma z? Hemnath, namaste sir, namaste Hemnath. Okay. So Hemnath, I think you are from AP, right? Okay. So namaste dear. So f of y comma z, is nothing but what? Is nothing but an integration constant. So how to determine this f of y comma z here? I have told, yes or no, how to determine? So you have to determine minus of integral what? Minus of integral Ey dy. In this you have to check whether you are getting any terms, whether you are getting any term that is a function of what? That is a function of only y, or function of only z, or a function of what? Both y and z. See here, f of y comma z means what here? This is the function which represents what? It may be a function of what? It may be a function of only y, or it may be a function of only z, or it may be a function of both y and z. So you have to determine this f of y comma z. So in order to determine that, you have to evaluate minus of integral Ey dy. So here you have to check whether you are getting any term that is a function of what? That is a function of only y or z, or both y and z, So similarly you have to evaluate minus of integral Ez dz. So from here also we have to check the same thing here. That means you have to check for the terms that are functions of what? Only y or z, or both y and z. So in this manner you can determine what? F of y comma z. Suppose if you are not getting any terms that is a function of only y or z, or both y and z, if you are not getting any terms like that while evaluating this one and while evaluating this one, then you can simply replace f of y comma z is equal to what? Is equal to 0. Understood? That means in that case, this integration constant will also go to what? Will also go to 0. Understood? Okay. And if you find any term here, okay, which is a function of only y or z, or both y and z, so that term you have to add here. Understood? Then it is going to give you what? It is going to give you the complete solution for the potential function. And I have said note points, yes or no? What are the note I have told here? What is the note I have told? So whenever you are evaluating minus integral Ex dx, minus integral Ey dy, minus integral Ez dz, whenever you are evaluating this, okay, what I have told here, don't include the common terms twice. Right, that's what I have told. So suppose if you are getting some term here, so the same term if you are getting here and here, okay, so don't include the common term twice. Understood? The same term you cannot include twice. Understood? Okay. Okay, so that's what I have told here. And what is another note I have told here? So whatever the procedure we are following, okay, so this procedure is based on what? Is based on A is equal to minus gradient of V relation. Yes or no? And this relation is valid only for what? Is valid only for what? Only for electrostatic fields. I have already told this one. Yes or no? So this is valid for only electrostatic fields. And it is valid only for what? Okay, electrostatic fields. Why it is valid for electrostatic field here? Because electrostatic field is what? Is a conservative field. Yes or no? So if it is conservative field means curl of E bar is equal to what? Is equal to 0. Yes or no? See, if you apply curl for this expression here, if you apply curl on both sides, what you are going to get? Curl of E bar is equal to 0. So that means electrostatic field is what? Is a conservative field. Is a conservative field. So whatever the method I have explained here, it is applicable only for what? Only for conservative fields. Right? Okay. Okay. So all these points I have explained in the previous session itself, right? Okay. So next we have solved some problems here, yes or no? So I have given one gate problem, that is some electric field they have given here, electric field they have given. So electric field they have given and asked to determine what? And asked to determine its corresponding potential function. Understood? Okay. So we have determined by using this method. Similarly, I have given another problem, the same problem, like I have given some electric field distribution and asked to determine what? And asked to determine potential function. Understood? Okay. So we have solved two problems here. We have solved two problems based on this method, right? Next, after that, I have given one problem as homework. I have given one problem as homework. Okay. So is anybody done homework here? Homework problem? Ankit Kumar, Alok Kumar. If you have watched the previous session, anybody has done that homework problem here? I have given to determine the work done, in moving the charge from A to B. So that is equal to Q into what? Q into VBA. So that is Q into VB minus VA. So using this one, you have to determine what? You have to determine the work done. Okay. So I have given one problem as homework here. Okay. So anybody has done that homework problem here? Tell me here. Anybody has done that homework problem? Tell me. At least anybody has tried that problem here? Anybody has tried that homework problem? See, why I am giving homework problem means at least you will revise at least once after the class. Okay. So if you try to solve the problem, you are just revising whatever we have learned in this class. Yes or no? Okay. Okay. No sir. Okay. Okay. Yeah. No problem. I will explain that. Okay. Okay. So before going to that homework problem here, so can you answer this question here? So this is given in gate here. This is given in gate 21. So this year they have given this question. Okay. So can you answer this question here? Tell me. I think this question is given for electrical students, right? Okay. See, even electrical students are getting more number of marks in this subject here. So this year approximately you got almost 5 marks. For 5 marks you have got from EMT. So two marks questions and one mark question you got, right? Okay. Okay. So can anybody solve this problem here? Tell me. See here, if anybody done this problem, give me the answer here. Try this problem and give me the answer. Okay. So meanwhile, I'll try to explain the problem. Okay. So those who already attending the regular classes, okay. So I hope they can easily solve this problem. So try to solve this problem on your own, right? So now here, what they have given here, a 1 microcoulomb point charge is held at the origin. A 1 microcoulomb point charge is held at the origin. If a second point charge, of 10 microcoulombs, if a second point charge of 10 microcoulombs is moved from 0, 10, 0 to 5, 5, 5 and subsequently to 5, 0, 0, then the total work done is, see what they are asking here, so a 1 microcoulomb point charge is held at origin. So you are having here, let us say here origin. Okay. So a 1 microcoulomb point charge, let us say that is Q. Q is equal to 1 microcoulomb. It is held at origin. Now if a second point charge of 10 microcoulombs, if a second point charge, let us say Q is equal to 10 microcoulombs, a second point charge is moved from 0, 10, 0 to 5, 5, 5 and subsequently to 5, 0, 0. Okay, so from, let us say this point here, let us say this point is A. Okay, so this point is, let us say B, and let us say this point is C here. Okay, so that means what is the initial point and final point here? The initial point is nothing but what? 0, 10, 0, and final point is nothing but what? 5, 0, 0. So that means finally the charge has moved from where to where? 0, 10, 0 to 5, 0, 0. See, I have already told that the work done in a conservative field doesn't depend upon what? Doesn't depend upon the path you are choosing. It depends only upon what? It depends only upon the initial point and final point. Yes or no? I have already told this point or not? Yes or no? Okay. So the work done in a conservative field doesn't depend upon what? Doesn't depend upon the path you are moving. It depends only upon what? Initial and final points of the path. Now here the initial point is nothing but what? 0, 10, 0, and the final point is nothing but what? 5, 0, 0. So that means you have to determine the work done. You have to determine the work done in moving the charge, in moving this Q amount of charge, from where to where here? From A to C, from A to C. That means you have to determine the work done from A to C. See, in generally that's what I have told here. In GATE questions, they are not specifically mentioning that work done by the external agent. Okay, actually they have to mention that here. They have to specifically mention that work done by the external agent like that. But they are not specifying that work done by the external agent. Understood? Okay, but you have to by default you have to consider always that work done by what? If they have not mentioned anything, means you have to consider work done by the external agent. Now here they are asking the total work done by what? By external agent. So this is what you have to understand here. This is what you have to understand. Okay, so they are not mentioning specifically, they are not using specifically these terms, but they have to use that. Okay, if they use this one, then the question will looks very neat and complete here, right? Okay, but in general, in most of the questions here, in GATE particularly, so whenever you see some IIT JEE questions, okay, so there they are using specifically work done by external agent, work done by the field force, so like that, net work done, like that, they are using each and every terminology clearly. Understood? But here they are not using that, but in general, by default, we have to consider the work done by the external agent. Understood? Now simply you have to determine what? Work done by the external agent in moving Q amount of charge from where to where? From A to C. Yes or no? So what charge you are moving? Q amount of charge from where to where? From A to C. So work done in moving the charge from A to C is nothing but what? Q into what? Q into VCA. Yes or no? Yeah? From A to C is nothing but what? Q into VCA. So that means you have to determine Q into what? VCA is nothing but what? VC minus VA. Just you have to determine the potential at C and potential at A. Understood? Okay. Now you are moving this charge. In which field here? In the field produced by this point charge or not? Yes or no here? You are moving this charge in the field produced by this point charge. That means the electric field that is produced here, is due to what? Is due to this point charge. Understood? Okay. Now here point A is nothing but what? Point A, let us consider some point A here, 0, 10, 0, and point C, let us say 5, 0, 0. So there is no need to draw the coordinate axis and all those things and try to locate the exact points and all. Okay. So in examination, if you try to draw the coordinate axis and try to locate the exact points, then half of the time will be consumed here itself. Understood? Okay. Just write down the initial point and final point. And what is the field produced by this point charge? So in this field, you are trying to move the charge from where to where? From A to C. Okay, I have chosen, it is not in an order here, I have chosen randomly from point A to point C you have to move. Understood? Okay. Okay, yeah. So now you have to determine. So in order to determine the work done in order to move the charge from A to C, what you have to do? Q into VCA, that is Q into VC minus VA. So that is equal to what? That is equal to Q into what? Q into, what is the potential at C here? What is the potential at C? So the potential at C due to this point charge Q, due to this point charge Q. So due to this point charge Q, what is the potential at C? Tell me. What is the potential here? So Q by 4 pi epsilon, the distance from here to here. So what is the distance from here to here? Is nothing but what? Is nothing but 5. Yes or no? So I am writing directly here. So VC is nothing but what? Q by 4 pi epsilon naught into 5 minus the potential at A. So what is the potential at A here due to this point charge? Is nothing but what? Q by 4 pi epsilon naught into distance from point charge to this point. What is the distance from here to here? Is nothing but what? 10 units. Yes or no? So you can write it as VA. VA is nothing but what? Q by 4 pi epsilon naught. Q by 4 pi epsilon naught into 10 units. Okay. So problem is completed. Right. Just you have to substitute the values here. So now here, Q is nothing but what? Q is nothing but 10 microcoulomb. So that is 10 microcoulomb. So here 1 by 4 pi epsilon naught you can take common here, or you can take Q by 4 pi epsilon naught common. Okay. So Q by 4 pi epsilon naught common means the Q value is how much? Q value is 1 microcoulomb. So that is 1 microcoulomb divided by 4 pi epsilon naught, divided by 4 pi epsilon naught into what? Into 1 by 5 minus what? 1 by 5 minus 1 by 10. Okay. Okay, yeah. Now 10 microcoulomb is nothing but 10 into 10 power minus 6. 1 microcoulomb is 1 into 10 power minus 6. 1 by 4 pi epsilon naught value we know. What is the value of 1 by 4 pi epsilon naught? That is nothing but 9 into 10 power 9. So here 1 by 5 is 0.2, 1 by 10 is 0.1. So 0.2 minus 0.1. Right. So completed your problem. Okay. So 10 power minus 6 and here 10 power minus 3. And here 10 power 9 will get cancelled. Yes or no? Okay. Okay. Now here you are going to get what? You are going to get 0.1. 0.1. Now here 10 and here 0.1. Understood? So what is left out here? 9 into 10 power minus 3. 9 into 10 power minus 3 joules. So that means 9 millijoules. 9 millijoules. Okay. So a single step problem here. That's it. Okay. So just you have to determine the work done by the external agent in moving the charge from A to C. So that is nothing but Q into VCA, Q into VC minus VA. So VC is the potential due to what? Due to this capital Q. So that is Q by 4 pi epsilon naught into distance from the capital Q to this point C. So that is nothing but 5 minus VA is nothing but what? VA is nothing but potential due to capital Q. Potential due to this capital Q charge at a distance, at a point A, that is 0, 10, 0. Understood? So the distance from here to here is nothing but 10. So Q by 4 pi epsilon naught 10. So if you solve this, you are going to get this answer, that is 9 millijoules. Understood? Okay. So it is simple or not? Yes or no here? Yes or no? So is it clear here? Is it clear? Tell me here. Alok Kumar, Ankit Kumar. Tell me, is it clear? Yes. Can we solve by Coulomb's law? Teja, yes sir. Alok Kumar, clear sir. Ankit Kumar, yes sir, clear. Okay. 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 How you can solve by Coulomb's law here? How you can solve by Coulomb's law? Here it is all about potential energy and potential, right? Okay. 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 So next, so we will see the homework problem here. Okay, so this is the homework problem I have given yesterday, I think. Yes or no? Okay, so this is the homework problem I have given here. So I am solving this problem here. Okay, so here what they have given here, what I have given, if electrostatic field E bar is equal to what? E bar is equal to 3x square yz minus 3y ax cap plus x cube z minus 3x ay cap plus x cube y plus z az cap. So this is the electric field distribution. This is the electric field distribution they have given. This is the electric field distribution they have given. So now you have to determine what? You have to determine the work done by the external agent in moving a charge, of Q is equal to what? Of Q is equal to 10 microcoulomb from point A to point B in the given electric field. See, whenever we are seeing this type of problems, that is whenever they are asking work done in order to move a charge from one point to another point. So in this type of problems, sometimes they are giving some charge distribution. Yes or no? Some charge distribution, like we have solved some problems here. So like we have determined the potential due to a circular ring. Yes or no? We have determined the potential due to a circular ring, and also we try to determine the work done in order to move some q amount of charge from 0, 0, 10 to 0, 0, minus 10. Yes or no? So here what they have given? They have given the charge distribution, and they are asking to determine what? Asking to determine the work done in moving the charge from A to B. So whenever they will give the potential, whenever they will give the charge distribution, you have to determine what? You have to determine its corresponding potential. Yes or no? Okay, so you have to determine its corresponding potential. So once you know the potential, then the work done from A to B is nothing but what? Is nothing but Q into what? Q into VBA. So by using this formula, you can solve the problem. Understood? So one thing is they are giving some charge distribution. In the previous problem also, they have given, that is gate problem here. Previously we have solved now. So in that problem also they have given what? They have not given the electric field distribution. They have given simply what? They have given simply a point charge. Understood? Okay. Now whenever they have given point charge, okay, so now they are asking to determine in order to move a charge Q from point A to what? From point A to C. So here what we have done, we try to determine the potential at what? The potential at A and the potential at what? Potential at C due to this point charge. We know the potential due to this point charge at point A and point C. So once we know that, then we have determined what? We have determined the work done from A to C is equal to what? Q into VC minus what? VC minus VA. So by using that, we have solved the problem. Okay, this is one way. Okay, so they may give the charge distribution and ask to determine what? Ask to determine the work done in moving the charge from one point to another point. So you have to determine the potential function due to that given charge distribution. What is the potential produced by that what? Produced by that charge distribution. Okay, so once you determine the potential, then it is very easy for you to determine the work done. So this is one type of problem they are asking. So what is another one here? So another one, they are not giving any charge distribution. They are simply giving what? They are simply giving the electric field distribution here. Simply they are giving electric field distribution, and finally they are asking to determine the work done from one point to what? From one point to another point in moving the charge from one point to another point. So in this case, how we are solving? So in this case also we are using the same formula, that is Q into what? Q into VBA. Understood? But here once they have given electric field, so from the given electric field distribution, we try to determine what? We are trying to determine the potential distribution. So once you know the potential distribution, then you can determine the potential at any point. Understood? So we can determine the potential at point B and you can determine the potential at point A. So once you determine that, then you can easily determine the work done in order to move from one point to another point. Understood? So in one case they are giving simply charge distributions, So due to that charge distributions, you have to determine the potential in order to determine the work done. Understood? So that is first model you can have. And the second model, what they are giving, so they are giving simply electric field, and they are asking to determine what electric field distribution they are giving and asking to determine the work done. So here from the given electric field distribution, we try to determine the potential function. So once you determine the potential function, then you can determine the work done. Understood? So these are the two models mostly they are asking here. Understood? Okay. Okay. So and also we have taken in this model, we have taken we have determined the potential due to a uniformly charged circular disk. Yes or no? So here also we try to determine the work done in moving the charge from point A to point B, like that. Yes or no? Okay. So I hope you remembered all these things here, right? Okay. So I am just explaining what are the models that they are covering. Okay. So you must have at least a brief idea of these models here, what they are asking, right? Okay. And don't worry, while giving the charge distribution, they are not going to give you some arbitrary charge distribution and ask to determine the work done. Okay. So they don't give like that. Okay. So they will give some charge distribution such that you can easily determine the potential due to that charge distribution. See, in the previous problem they have given in gate, they have given simply a point charge, and we can easily determine the potential due to that point charge. Yes or no? Okay. Okay. Yeah. Okay. So coming to this problem, so here they have given what? Field distribution and asking to determine the work done. Understood? So once they have given field distribution, you have to determine what? You have to determine the potential distribution. So how to determine the potential distribution here? What I have told. So you have to consider whenever they have given the field distribution. So first of all, note down what is X component and what is Y component of electric field and what is Z component of electric field. Understood? So first what you have to do, you have to determine the potential distribution from the given electric field distribution. Okay. So we know that the work done from A to B here. I don't write every time external agent here. So by default you have to consider that it is work done by the external agent. Okay. So here anyway I have given in the problem here. So whatever the problems that I have designed, okay, so for those problems I am specifically mentioning external agent, but in gate problems they are not mentioning that. If you go through any physics textbooks also, they will definitely represent this term here, external agent. Understood? Okay. Okay. Anyway, so here work done from A to B is equal to what? Is equal to Q into what? Q into VBA. So that is equal to Q into VB minus VA. So this is what you have to determine. This is what you have to determine. Okay. So that means you have to determine, once you determine the potential distribution function, then you can determine the potential at B and you can determine the potential at A. So just substitute all this, you are going to get the work done. Right. Okay. So I have told how to determine the potential function whenever they have given the electric field distribution. So what is the process here? So V is equal to what? I am taking the first equation, that is V is equal to minus of integral Ex dx plus what? Plus f of y comma z. F of y comma z. Now here this is equal to what? Minus of integral Ex is nothing but what here? 3x square yz minus 3y into what? Into dx plus what? Plus f of y comma z. So okay, so you guys do parallel here. You guys try to solve the problem parallelly. Okay, so let me know what are the answers that you are getting. Okay, so later you can check here. Later you can check if you are getting anything wrong. Then later you can check. So but try to solve the problem along with me. Right? Okay. So now this is equal to minus of integral. So what is the integration of this one here? 3x square yz dx. What is the integration of this one? I am writing directly here. Okay. So minus of 3x cube by 3yz minus 3xy. So this is the integration. Yes or no? Plus what? Plus f of y comma z plus f of y comma z. Now here 3 will get cancelled. So you are getting what here? Minus x cube yz plus what? Plus 3xy plus 3xy plus what? Plus f of y comma z. So this is the potential function you are getting. So here what is the unknown here? F of y comma z is the unknown. Here the unknown is nothing but f of y comma z. So how to determine f of y comma z? What I have told here, if you want to determine f of y comma z, what you have to do? You have to evaluate minus integral ey dy, and you have to check whether you are getting any terms that is a function of only y or z or both y and z. Okay, now here what is ey here? What is ey? So ey is nothing but what? X cube z minus 3x, x cube z minus 3x. Okay, so minus of integral x cube z minus 3x, right now, x cube z minus 3x, right? Okay, so if you do this here, what you are going to get? You are going to get minus of x cube y z minus what? Minus 3xy. So if you observe this term, you are not getting any term that is a function of only y or a function of only z or a function of both y and z. Understood? You are not having any term like that. Understood? Next, what you have to do here? You have to evaluate another one, that is integral minus ez dz. Now minus of integral, what is ez here? What is ez? Ez is x cube y plus z, x cube y plus z. Okay, so x cube y plus z into dy. So if you integrate this one, what you are going to get? Tell me. So if you integrate, you are going to get x cube into y square by 2. You have to integrate with respect to what? With respect to z. Okay, if you integrate with respect to z, what you are going to get? You are going to get x cube y z plus what? Plus z square by 2. Understood? Okay, so here whenever you are evaluating minus ey dy, you have not find out any terms. That is a function of only y or function of only z or function of both y and z. Now if you consider, whenever you are evaluating this term here, whenever you are evaluating this integration, what we got here? We got minus of x cube yz plus z square by 2. So that means here this term is not a function of only y or only z or both y and z. Understood? Okay, it is having x also, right? Okay, so next, if you observe this term here, so this term is a function of what? Is a function of only z. So we are looking for the terms which are only functions of y or only functions of z or only functions of both y and z. Yes or no? Now if you observe this term z square by 2 is a function of only z. So that means you have to consider this term here. So here don't forget this minus sign here. So you are multiplying with what? Minus. So here what is the term you got here? Minus z square by 2. So that means in place of f of y comma z, you have to replace with what? You have to replace with minus z square by 2. Okay, so then you are going to get what? You are going to get the complete solution. Now here f of y comma z, you have to replace with what? Minus z square by 2. Okay, so that is the potential here. So v is equal to what? V is equal to minus x cube y z plus what? Plus 3xy minus z square by 2. So this is the potential function here. This is the complete solution of the potential function. So for a given electric field distribution, this is the potential function, right? Okay, so now they are asking what here? They are asking the work done in order to move the charge from where to where? From point A of 2, 3, 5 to B of 1, 5, 7. Okay, so now just substitute all these values here. What you are going to get? So Q is equal to what? Q is equal to 10 microcoulomb. So Q value is equal to 10 microcoulomb. So that is 10 into 10 power minus 6. So what is the potential at B here? So what is the potential function we got? So I am writing, I will copy this one here, right? Okay, see here. So I am copying here. So this is the potential function. Now what is the potential at B? So at B, so point B is nothing but what? Point B is nothing but 1 comma 5 comma 7, right? And point A is nothing but 2 comma 3 comma 5. Point A and point B is 1 comma 5 comma 7 na? Okay. Point B is 1 comma 5 comma 7. Okay. Now just substitute here, just substitute all these values, that's it. So VB is equal to what? VB is equal to, so anybody has done this problem here? If anybody done this problem, please give me the answer, what you are getting. VB of 1 comma 5 comma 7 is equal to what? Is equal to, so substitute these values here. So minus 1 whole cube, y value is 5, z value is 7, plus 3 into 1 into 5 minus 49 by 2. Yes or no? Z square, that is 7 square. 7 square by 2 means 49 by 2. Okay. So this is the potential at B. So you will get here minus 35 plus 15, right? Okay. And here minus 49 by 2. So determine this value here. Determine this value. So tell me these values here, at least tell me these values. What is VB you are getting? Calculate and tell me the values here. So VA is equal to what? So point A is nothing but 2 comma 3 comma 5. So substitute those values here. Minus 2 whole cube, minus 2 whole cube into 3 into 5 plus 3 into 2 into 3, 3 into 2 into 3 minus 5 square by 2. So that is 25 by 2. So tell me these values of the potentials here. Tell me. So VA is equal to 8 3s are 24 into 5 here. Here you are getting minus of 24 into 5, right? Plus you are going to get here 18 minus 25 by 2. So determine this value here. Determine this potential VA. So here determine this potential VB, right? So what is VB and VA values here? Tell me. Minus 44.5 and another person is giving you 51 by 2. Okay, okay, I will check here. So minus 35 plus 15 minus 20 minus of 49 divided by 2. Okay, so here you will get minus 44.5, right? Alok Kumar, yes, minus 44.5. And VA value is minus 24 into 5 plus 18 minus of 25 divided by 2. Okay, so I think this value is minus 114.5 here, minus 114.5. Anybody got this value here? VA, is it correct? Minus 114.5. So here it is minus 120, right? So minus 120 plus 18 is minus 102, right? So minus of 25 by 2, that is 12.5. Yes, minus 114.5. What you are getting here? Minus 23.5. Check this here. Minus x cube is 2 cube, y value is 3, z value is 5. So 8 3s are 24, 24 into 5 is 120. So this value is minus 120, right? Next 3xy, so that is 3 into 2 into 3, so that is 6 3s are 18. So you are going to get 18 minus z square by 2, that is 5 square by 2, that is 25 by 2, right? So you are getting here minus 120 plus 18 is minus 102, minus 102 minus 12.5. 25 by 2 means 12.5. So if you add up, you are going to get minus 114.5. Alok Kumar, please check here. Okay. Yes, minus 114.5, right? See, don't worry if you do some mathematical calculations mistakes also, don't worry here, okay? So you have to learn each and everything. So if you do mistakes also, no problem, okay? But you have to keep trying here, whether you do mistakes or not, it doesn't matter, okay? But you have to keep trying the problems, right? Okay. Next, VB. What is VB here? VB is minus 44.5 minus VA is minus 114.5, that is minus 114.5. Okay. So you have to determine this one. So 10 into 10 power minus 6 into what? Into minus 44.5 plus 114.5 here, minus 40. What is the answer you are getting? Tell me. So minus 44.5 plus 114.5 is 70. Yes or no? So it is nothing but 70 here. So you will get 700. You will get 700 microjoules. You are getting 700 microjoules. Okay. Or you can write 700 microjoules. Okay. Or you can write, I think, 0.7 millijoules. Okay. Okay. So 700 microjoules. So this is the work done from A to B. Right. So everybody got this answer here? Yes or no? Tell me here. Everybody got this answer? Yes. Alok Kumar. Alok Kumar, Teja, Ankit Kumar. Tell me here. Everybody got this answer? Yes? Okay. Right? Okay. Next, try to solve this problem here. Try to solve this problem. So what they have given? Same question here. Find the work done. Okay, same model. Find the work done in moving a point charge Q is equal to minus 20 microcoulomb. They have given Q is equal to minus 20 microcoulomb from 0, 0, 0 to 4, 2, 0, from 0, 0, 0 to 4, 2, 0 in the field, in the electric field here. In the electric field, E bar is equal to what? 2 into x plus 4y ax cap plus 8x ay cap along the path x square is equal to what? Along the path x square is equal to 8y. Okay. Okay. So can you solve this problem here? Tell me. So they have given Q amount of charge. You have to move this Q amount of charge, that is minus 20 microcoulomb from point A. From point A. What is the point A? They have given 0, 0, 0 to what? To point B. That is nothing but what? 4, 2, 0 along the path. Along the path they have given x square is equal to 8y. See, do we need any path here? Do we need path? Do we need any path? Yes. The work done in a conservative field is independent of what? Is independent of the path. Yes or no? Okay. So we don't need this one here. We don't need this one. if you are following our method, so that is the work done in order to move from A to B is equal to what? Is equal to, here they have given point charge Q, so Q into what? Q into VBA. So that is equal to Q into what? Q into VB minus VA. So in order to determine the work done, first of all you have to determine the potential function. So they have given here electric field distribution. So from this electric field distribution you try to determine the potential function. So once you determine the potential function, then you can determine this work done in order to move the charge from A to B. So we don't need this path and all here. Understood? Okay, so whether they will give the path or not, it doesn't matter for us. But if you follow another method, what is another one here? See here, if you want to determine like this, work done from A to B is equal to what? Is equal to Q into VBA. I can write it as what here? VBA. I can write it as integral B to A E bar dot what? E bar dot DL bar. So if you use this expression here, if you use this one, then you, in order to solve this integration, they have given E bar. Yes or no? They have given E bar, and here DL bar is nothing but what? DL bar is nothing but dx ax cap plus dy ay cap plus what? Plus dz az cap. And they have given this electric field distribution also. Now we have to solve this integration. Yes or no? Okay, so in order to solve this integration here, if you want to solve this integration, so sometimes it will be somewhat difficult to solve the integration here. Why? Means it is a lengthy process. See, without the help of this path here, so they have given along the path x square is equal to what? X square is equal to 8y. So without taking the help of this path, it is not possible to solve this integration. Understood? So you have to take the help of this path, and whenever you are integrating with respect to x, so in that case, if the function is having y, so wherever you are having y, there you have to replace with x square by 8, then you have to integrate with respect to x. Similarly, whenever you are integrating with respect to y, so wherever you are having y, there you have to replace y with what? There you have to wait, what I am saying here, whenever you are integrating with respect to y, if you are having any x term here, then in place of x you have to replace with what? Root 8y in order to solve the integration. See, what I am saying here is, see, this is, you are going to have what? So here you are going to have E bar is nothing but ex ax cap plus ey ay cap plus ez az cap. So it is having x component, y component and z component. Yes or no? So if you do the dot product, what you are going to get? Ex dx. Yes or no? Okay, so ex dx, so you are integrating from A to B, ex dx plus ey dy plus what? Plus ez dz. Right. Now suppose if ex here, if ex is, let us assume ex is xy, if you are having xy. Okay, so ex, here ex is a function. What I am saying here is this x component, if this x component ex, if suppose they have given as xy, understood, then compulsory you have to take the help of this path here. Why? Means here you are integrating, here this x component you are integrating with respect to what? With respect to x, So whenever you are integrating with respect to x, you have to replace y. You have to replace y with what here? Y with x square by 8. Understood? Then you have to solve the integration. Right. Similarly, whenever you are doing integration with respect to y here, if suppose ey you are having x square y here, if you are having xy square, let us assume the ey term, if you are having xy square, so then in place of x here, here you are integrating with respect to y, so in place of x you have to replace with what? You have to replace with root 8y. Then you have to solve this integration. So everywhere wherever you are having x, there you have to replace with y. Okay, while integrating with respect to y. Understood? So you have to take the help of this path in order to solve this integration. So otherwise it is not possible to solve the integration. Understood? Okay, that's the problem here, that's the problem. So it will become a lengthy procedure here, it will become a lengthy procedure. So that's why we are not following this procedure. This procedure is not wrong here, this procedure is correct. Okay, but it is very lengthy. So it is very lengthy, this method is very lengthy. So that's why we are not following, I am not following this method here, right? So if you are comfortable with this, you can follow that, but I won't suggest to follow this method because it is very lengthy and you have to take the help of whatever the path they have given, you have to take the help of that path. Otherwise it is difficult to solve the integration. Understood? Okay. So that's why we are following this simplest method, right? Okay. So whatever the path they will give, okay, it doesn't matter, whatever the path they will give, it doesn't matter, we can easily solve this problem with the help of this one. Understood? Okay. So if you determine the potential, then it is going to be very, very simple, right? Okay. Okay. Do this one here, do this one and tell me the answer here. I am waiting. So I will give how much time you want here. So let us take 30 seconds here. Okay. So within 30 seconds I need answer for this question. Okay. Do it here, do it. Just you have to determine the potential function. So what I have told, just take this as what? Just first of all write the x component and here write this is nothing but what? Y component. And I have told you how to determine what? Potential function. Yes or no? So you can use any of the three equations. So generally we are using this one, so we continue with this one. So that is v is equal to minus integral ex dx plus f of y comma z. And how to determine f of y comma z, that I have told. Yes or no? So do this one, determine the potential function, the complete solution of the potential function. So once you know the potential function, then you can determine the potential at B and you can determine the potential at A. Just substitute those values, multiply with Q, will give you the work done, right? Okay. Do it here, do it. Do it here. So we have solved many problems here. Okay. So do this problem here. Same type of problems we have already solved. Okay. So do this one and tell me the answer here. Alok Kumar, Teja, tell me the answer for this question. See, the answer may be wrong or right. Okay, it doesn't matter. So please try this one and tell me the answer. Whatever that you are getting, please write it in a chat box. Whether it is wrong or correct, it doesn't matter here. Okay. Now you have to learn each and everything, right? So if you do mistakes also, you will understand where you are doing mistakes and where you are feeling problem. Okay. So then after that, for next time you can rectify that mistakes, right? So as we proceed in this manner, so later as the time proceeds, you will get the perfection. Okay. So slowly with practice, these mistakes will be reduced and you will get perfection here while doing the problems, right? Okay. So don't worry about giving the right answer or wrong answer, it doesn't matter. Okay. So at least try the problem and give me the answer. Tell me here. Okay. So if anybody done this one, please give the answer. At least if you give some answer, whether it is correct or wrong, it doesn't matter. If you give some answer, I will feel somewhat happier, because we are practicing this. Yes or no? We are practicing this from last session. Yes or no? Okay. So it is very simple procedure here, right? Okay. Okay, yeah. So v is equal to what? V is equal to minus of integral x component is 2 into x plus 4y dx plus f of y comma z plus f of y comma z. So how much here? Teja VA is equal to 0, Alok Kumar 96. Okay. Okay, VA is equal to 0. Okay. What is VB? So determine VA and VB, both you have to determine, yes or no, in order to determine the work done. So Alok Kumar, you are getting 96. Okay. Okay, let's see. So V is equal to minus, if you do this integration here, what you are going to get? 2 into x square by 2 plus 8xy plus 8xy plus f of y comma z plus f of y comma z. So 2 will get cancelled. So you are getting what? Minus of x square plus 8xy, x square plus 8xy plus f of what? Plus f of y comma z. Now you have to determine f of y comma z, f of y comma z. How we can determine here? You have to evaluate minus of integral ey dy. If you evaluate this one, what you are going to get? Minus of integral. What is y component here? What is y component? Y component of the field is 8x, and there is no z component of the field here. There is no z component of the field. So there is no need to evaluate minus integral ez dz, because there is no z component here. Okay. So just consider this y component. Y component is 8x. Yes or no? Okay. So here minus 8x into dy. So that is equal to what? Minus 8xy. Minus 8xy. So that means you are not getting here, you are not getting any term that is a function of only y or a function of only z or a function of both y and z. Okay. So and if you try to evaluate integral ez dz, what you are going to get? You are going to get 0, because ez is equal to what? 0. Understood? Okay. So that means if you evaluate this one and this one, you are not getting any term that is a function of only y or only z or both y and z. Okay. So that means you can simply replace f of y comma z with what? With 0. With 0. Okay. So therefore v is equal to what here? Therefore v is equal to what you are getting? Minus of x square plus 8xy, and f of yz is equal to 0. So just replace f of yz with 0. That's it. Okay. So now you got the potential function. You got the potential function. Now you have to determine the potential at A and B. So the potential at A here, A is nothing but what? 0 comma 0 comma 0. So if you substitute that, you are going to get what? 0. And potential at B. So what is B here? B is nothing but what is the point B? 4 comma 2 comma 0. So B is 4 comma 2 comma 0. So substitute these values here. So minus of so x square, that is 4 square, that is 16, plus 8 into 4 into 2. So that is 32 into 2, 64. So 64 plus 16 here. 64 plus 16 is how much here? 80. So here you are having minus. So you are getting VB is equal to what? VB is equal to minus 80. Yes or no here? VB is equal to minus 80. Okay. So now here substitute these values here. So here you are going to get work done in order to move from A to B. Work done from A to B is equal to what? Is equal to Q into what? Q into VB minus VA. So what is Q value here? What is Q value? Q 5 microcoulomb or what? What I have given? Minus 20 microcoulomb. Okay, right. Minus 20 microcoulomb. So here Q value is minus 20 microcoulomb, that is minus 20 into 10 power minus 6 into what? Into VB. VB is minus 80, right? VB is minus 80 and VA is what? VA is 0. So minus 0. Okay, so what you are going to get here, minus into minus will become plus. So 80 into 20, how much you will get here? 1600 into 10 power minus 6 joules. 1600 into 10 power minus 6 joules. So this is the work done from A to B. Okay, so that means you are getting how much here? You are getting 1600 microjoules. 1600 microjoules. So if you want to write in terms of millijoules, so you can write it as what? You can write it as 1.6 millijoules. So or you can write it as 1.6 millijoules. Okay, so this is the work done in order to move the charge from A to B. This is the answer here, right? Okay. Okay. So you got minus 80 volt. Very good here. Okay. So if you got minus 80 and another one will be 0, so just it is a simple multiplication of Q into VB. So you are going to get this one, right? Okay. So I hope everybody got this answer here. So that is 1600 microjoules or 1.6 millijoules, right? Okay, fine. Okay, this one here, this one you have to tell me the answer. This one you have to tell me the answer here. This is somewhat important here. Most of the times they are asking the questions based on this. Okay, so that's why I have given this one. Okay, so here find the work done in moving a point charge Q is equal to 5 microcoulomb from origin to what? From origin to 2 comma minus 1 comma 4 through the field. So they have given the electric field here. They have given the electric field distribution via the path from 0 comma 0 comma 0 to 2 comma 0 comma 0, and then from 2 comma 0 comma 0 to 2 comma minus 1 comma 0, and then from 2 comma minus 1 comma 0 to 2 comma minus 1 comma 4. Okay, so you have to follow this path. If you okay, but here we know that electrostatic field is a conservative field. So if we follow our method, that is work done from initial point to final point. So let us consider this initial point here. Initial point is origin, so consider this point as A, and final point, consider this point as B here. Okay, so work done from A to B is equal to what? Q into VBA. So if you follow this method, we don't need this path and all here. But if you follow that integration of E bar dot DL bar, if you try to evaluate, okay, integration of E bar dot DL bar, then you have to take the help of this path. Understood? You have to take the help of this path. Understood? But that procedure is lengthy, so that's why we can avoid that method completely, and you can solve in this method. Okay, so irrespective of the path, whatever the path they will give here, we don't mind, because our electrostatic field, the beauty of our electrostatic field is it is a conservative field. So it doesn't depend upon the path, it depends only upon initial and final points. So if you know initial point and final point, that's it. Okay, we don't want anything else, right? Okay, so we know that whenever they give electric field, we can determine its corresponding potential function. So once you determine the potential function, then you can, by using this formula, you can determine the work done. Yes or no? So tell me the answer here. Tell me the answer. Work done from A to B is equal to Q into what? Q into VB minus VA. Just follow this one. Okay, so previously they have given the path like what? They have given the path like x square is equal to 8y or something, or y is equal to 8x, something, some path they have given. But irrespective of that path, we have determined. Yes or no? Here they have not given the path in this manner, but they have given you a clue that if you follow this path, you have to follow this path in order to determine the work done. Okay, so if you follow this path here, then you can evaluate E bar dot DL bar. In order to evaluate integral A to B E bar dot DL bar, then compulsory you have to take the help of this path. So otherwise it is not possible to solve this integration. Okay, so I said it is a lengthy process, so we are not worried about this path and all. Okay, Because why we are not worried about this path? Because our electrostatic field is a conservative field, and already I have told that these methods, electrostatic potential and electrostatic potential energy, all these are defined only for conservative fields, the concept of potential and the concept of potential energy are defined only for conservative fields. You should not apply these methods, okay, if the field is non-conservative. But here we are not going to deal with non-conservative field, we are dealing with what? Conservative field. Understood? So don't worry about that, right? Okay, so do this problem here, do this problem and tell me the answer. Okay, so 30 seconds here, 30 seconds. Simple. I am not giving some tough calculations also. I am giving simple functions. Okay, you can easily integrate. If you know integration, you can get the answer. That's it, right? Very good, Teja. VA is equal to 0, VB equal to 16. Very good, very good. Okay, whether it is correct or wrong, it doesn't matter. So you have tried and you are giving the answers. That's very good. That's very nice, right? Okay. If anybody done the problem, please give me the answer here. So then once you have determined VB and VA, then determine work done from A to B. That's it now. So what is the charge they have given? What is the charge you are moving? What is the value of the charge that is moving? You are moving Q equal to 5 microcoulomb. So substitute Q is equal to 5 microcoulomb here and substitute whatever VB value you got and here substitute whatever VA value you got. Understood? So if you substitute, then you are going to get what? You are going to get the value of work done. So tell me what is the work done you are getting? 80 microjoules. 80 microjoules. Okay, you are getting 80 microjoules. Okay, very good here, very good. Anybody done the problem here? Teja has given the answer. Okay, so let us check whether it is correct or wrong. So this is always write down these components first: Ex, Ey, Ez. Okay, so V is equal to, so I am writing directly here, minus of integration of this Ex. So what is the integration of this x component here? So that is nothing but 2 into x square by 2 yz. Okay, I am doing directly here. Okay, plus f of y comma z. So here 2 will get cancelled. You are getting minus of x square yz plus what? Plus f of y comma z. F of y comma z. Okay, now there is no need now again doing all these things here. We know how to determine f of y comma z. That is, you have to evaluate what? Minus of integral ey dy. See here, ey is nothing but what? X square z. So if you integrate this one, you are going to get what? X square yz. If you integrate this one with respect to y, what you are going to get? X square yz. So x square yz is not a function of only y, or not a function of only z, or not a function of only y and z. So here you are having x square also. Understood? Okay, so that means here you are not going to get any term that is a function of only y or z, or both y and z. So next, what you have to evaluate? You have to evaluate minus integral Ez dz. So take integral Ez dz here. So here you are having x square y. So if you integrate this one with respect to z, what you are going to get? You are going to get x square yz. So x square yz, just now we have seen, here also we got x square yz, here also you are getting x square yz. So x square yz is not a function of only y or z, or both y and z. So it is a function of x, y and z. So we don't want that term. Yes or no? We are checking for the term that is a function of only y or z, or both y and z. So here also you are not getting anything. So that means you can just simply replace f of yz is equal to what? Is equal to 0. So therefore the total the complete solution of the potential function is simply minus x square yz. So in this manner, if you practice further more and more problems, so in this manner you can easily solve the problem within 1 or 2 steps here. Okay, so the calculation will also become very fast if you practice. So V is equal to minus x square yz. Now it's just a matter of substitution. So work done from A to B is equal to what? Is equal to Q. Q is equal to 5 microcoulomb, that is 5 into 10 power minus 6 potential at B. So what is point B here? Point B is nothing but 2 comma minus 1 comma 4. Yes or no? So 2 comma minus 1 comma 4, and point A is nothing but 0 comma 0 comma 0, right? So just substitute those values here. So minus of x square yz, that is 2 square, y value is minus 1 into 4, and VA you will get 0, right? So what you are going to get? So 5 into 10 power minus 6, 5 into 10 power minus 6, here minus will become plus. So you are going to get what? 4 into 4, 60. Okay, so you will get 80 microjoules, 80 microjoules, right? Very good, yeah, very good, very good. So Alok Kumar, you also got 80 microjoules. Teja, you also got 80 microjoules. Very good. Okay. Okay, yeah. Okay. So I hope you got familiar with this type of problems, right? Okay, fine. Very good. Okay, yeah. Okay, see here. So up till now we have solved the problems here. We have solved the problems that is based on work done in order to move a charge from one point to another point. Yes or no? So if they give electric field distribution, how to determine its corresponding potential. Okay, so all these things we have seen. Okay, so we have mostly solved the problems. Most of the problems, 90% of the problems we have solved based on what? Based on case 1. Okay, so what is case 1 here? The net force acting is equal to what? Is equal to 0. So if the net force acting is equal to 0, then I have told that what? I have told that the change in kinetic energy is equal to 0. So in this case, the net work done is also equal to 0. So another one, what I have told here? So in this case, the work done by the external agent is equal to what? Minus of work done by the field. Yes or no? Okay, so based on this we have solved different types of problems. So this will come under case 1, right? Okay, next in case 2 here, so in case 2 what I have told here, if the net force acting on the object is not equal to 0, then we will apply what? We will apply law of conservation of energy concept in order to solve the problems. Okay, so if net force is not equal to 0 here, if net force is not equal to 0, then what will happen here? There will be a change in what? There will be a change in kinetic energy. Yes or no? Why here? Because if the net force on any object is not equal to 0, so that means that object is going to what? Is going to accelerate. That means its velocity is going to change. Because we know that F net is equal to what? F net is equal to what? Is equal to m into A, where A is nothing but what? dV by dt. Understood? So here, whenever net force is not equal to 0, then that object is going to accelerate, acceleration or deceleration, whatever it may be. So it is nothing but what? dV by dt. So dV by dt represents what? Change in velocity with respect to time. So if the velocity is changing with respect to time, then its kinetic energy is also going to change. So in this case, the change in kinetic energy is not equal to 0. Yes or no? Okay, so now in this case the net work done, what do you mean by net work done here? The work done by the external agent plus the work done by the field force. Okay, so that work done, the net work done is not equal to what? Is not equal to 0. Whereas in this case, the net work done is equal to what? 0. That means if you consider the work done by the external agent plus the work done by the field force, both are what? Both are same but opposite polarity. So if you add these two, what you are going to get? You are going to get 0. Understood? So all these things we have studied here already. So you should not forget whatever the problems we are solving. Okay, you should not forget the basics here. Okay, always you have to revise that basics. Understood? Okay, so the basics are very important. right? So F net is equal to m into a, that is dv by dt. So that means if the net force acting on the object is not equal to 0, then change in kinetic energy is also not equal to 0. So in this case, the net work done on the object is also not equal to 0. So in this case, what I have told here, the total energy, the initial total energy is equal to what? Final total energy. Yes or no? Okay. So I have proved this one also. I have proved this one also. Yes or no? Okay. So this is nothing but what? This is nothing but law of conservation of energy. So what do you mean by law of conservation of energy? The total energy at any instant of time must be what? Must be constant. So this total energy should not change with respect to time. The total energy in the system should not change with respect to time. So then we can call it as what here? Law of conservation of energy. At any instant of time, the total energy within the system must be constant. So that means if the total energy is constant at any instant of time means then if you differentiate the total energy with respect to time, what you are going to get? You are going to get 0. Okay. So with the help of this one, we have derived this one. Yes or no? Okay. So I hope you have remembered all these things here, right? So case 1 and case 2, understood? Okay. So now up till now we have solved most of the problems that is based on case 1. Now I will give you a simple problem here. I will give you a simple problem that will come under case 2. So that means the net force acting on the object is not equal to 0. Okay. So in that case, how we have to solve the problems? Understood? Okay. Already we have solved one problem here, that is a gate problem they have given, that is a Q1 charge, that is electron. So a electron is projected towards what? Towards a stationary electron. Another stationary electron is present at some location. Now Q1 electron is projected towards what? Towards Q2. Yes or no? With some velocity v is equal to 10 power 5 meters per second or something. Understood? So whenever it is projected towards Q2, so they are asking to determine the minimum distance between Q1 and Q2. Okay. So before that Q1 diverts its path. So I hope you can remember that problem. If you are attending regularly, I hope you can remember this problem here. So this problem, what we have done here, we have considered the total initial energy and we have equated the total initial energy to what? The total final energy. So from that we have determined the minimum distance between what? Between Q1 and Q2. So this is the only one problem I think we have solved based on what? Based on case 2. Right. So here okay. Yeah. So you can revise this problem here. We have explained this one. Okay. I have explained in the previous sessions, so you can go through this problem. This is previous gate question. Okay. Yeah. So now see here. See. Now see, let us say you are having a charge capital Q. Right. Now let us say at some distance r, you have placed another charge here, some small q. So let us say this capital Q is fixed. Here. So it is fixed at this location. Understood? Now you have brought this Q amount of charge from infinity to this location and placed at this location. So in order to bring this Q amount of charge from infinity to this location, you have to do some work. So whatever the work you have done, that will be developed as potential energy. That we know. Yes or no? So now if I place the charge at this location, then what is the potential energy of this system here? We know that the potential energy of this system is equal to what? Q divided by what? Divided by 4 pi epsilon into R joules. Yes or no? Okay. So whenever you place the charge at this location, so what are the forces that are acting here? What are the forces that are acting on this charge Q here? See, this capital Q is fixed. Understood? Okay. So it is not going to move. So now here this Q, I have placed this Q at this location. And if I assume the Q is present at this location, then what are the forces that are acting on this Q here? So one is what? One is electrical force. So that is acting in this direction. Electrical force is going to act in this direction. Yes or no? Because I am considering this capital Q and small q as what? Same polarity, same polarity. So that means it is going to experience a electrical force in this direction due to this capital Q. So in order to place this charge at this location, you have to apply a force. Yes or no? You have applied a force, external force. Yes or no? External force in this direction. Yes or no? Yeah. Okay, so from infinity here, from infinity what you have done, you try to move this point charge Q from infinity to this location, infinity to this location. So in order to move this capital Q from infinity to this location, you have done work. So that is the work done by what? Work done by the external agent. So external agent has to apply a force always opposite to what? Opposite to electrical force. Understood? Okay. So in this case, I have told that the net force acting on the charge will be equal to what? Will be equal to 0. Will be equal to 0. Understood? Okay. Now what we will do here is, if I release this external force here, if I make F external is equal to 0, F external is equal to 0. So I have moved the charge from infinity to this location. Now the external force is acting in this direction and electrical force is acting in this direction. The net force on this charge will be 0. So it is staying here at this location. Now what I am doing here is, if I just release the external force here, so that means in this direction there is no force. If I just release external force, that means external force I am making it equal to 0. Understood? So then what will happen here? Tell me. Then what will happen? Tell me here. So I am removing this external force here. There is no external force acting on this charge. Okay. So in this case, what happens to this charge? What happens to this charge? Tell me. I have removed the external force on the charge here. So F external I am making equal to what? Equal to 0. Understood? Okay. So external agent is not applying any force on this charge. Now what is the only force that is acting on this charge here? What is the only force that is acting on this charge? There is no external force. That means what is the only force that is acting on this charge? Is nothing but what? Is nothing but electrical force or not? Yes or no? Yeah. So that means in this case, F net on the charge is not equal to what? Is not equal to 0. Is not equal to 0. So what is the net force acting on the object here? What is the net force acting on this charge here? Is nothing but what? Is nothing but only one force is acting. That is nothing but what? Electrical force. Okay. So whenever there exists a net force on the object, whenever the net force acting on the object is not equal to 0, then what happens to that charge? Tell me. Tell me here. Alok Kumar, tell me. Then what happens to that charge here? If the net force acting on the object is not equal to 0, then what happens to that charge? Tell me. Just now I have told, if the net force is not equal to 0, then what will happen? Tell me here. In physics, in +1 or +2, you have studied, I think, Newton's second law and all these things. Yes or no? Okay. What you have studied here? What you have studied? So a body continues to be in its state of rest or state of motion unless until it acts upon by any external force. Yes or no? Unless until it acts upon by any net force. If the net force acting on the object is not equal to 0, then then the state of the object is going to change here. The state of the object is going to change. That means what here? If it is moving with uniform velocity, let us assume some object is moving with uniform velocity. Okay. Now if you apply an external force on that object here, then what will happen? Its velocity is going to change. Its velocity is going to change. Yes or no? Now suppose if the body is at rest, now if you try to apply the force, if you apply a force on that object, then also its velocity is going to change. Yes or no? Okay. So that means whenever you apply the force, its velocity is going to change. Now once you remove the force here, there are no forces acting on the object. So now if the object is let us assume the object is moving with some constant velocity. Now you are not applying any force on that object. Then what will happen? It continues to move with the same velocity up to what? Up to infinite distance. Here I am assuming there are no opposing forces acting on the object. The forces that are acting on the object is equal to 0. So in that case, if the body is continuing with the with some constant velocity, then it continues to travel with the same velocity up to what? Up to infinity. Yes or no? Okay, or if the body is at rest and if you are not applying any force on that object, then it continues to be in rest forever. Or if it is moving with constant velocity and if you are not applying any force on that object, then it continues to be in move with the same velocity forever. Okay, so that means in order to change the state of the object, you have to apply what? You have to apply a force. That means if it is in rest, then if you apply a force, then its state is going to change. That means its velocity is going to change. Yes or no? Now if it is moving with uniform velocity, constant velocity, then if you want to change its state, that means if you want to change its velocity, then you have to apply the force. Okay, so if the net forces acting on the object is not equal to 0, then its velocity is not going to change. If the net force is equal to 0, then its velocity is not going to change. Velocity will be constant. That constant may be 0 or may not be equal to 0. Yes or no? 0 is also a constant or not? Yes or no? So if I say v equal to 0, I can say it as constant velocity, and constant velocity is equal to here 0. Understood? So the object will move with always with constant velocity if the net force acting on the object is equal to 0. So if the net force acting on the object is not equal to 0, if it is experiencing any net force, then its velocity must change. Its velocity must change. Understood? Okay, so keep these points in mind here, right? Not in equilibrium. Okay, what I am saying, whenever some net force is acting on the object here, the net force acting on the object is not equal to 0, then what happens to this charge? See, here capital Q is present. So small q, I have brought small q from infinity to this location. So in order to bring this small q, I have done some work. So whatever the work I am doing, that will be developed as or stored as potential energy. Now I have brought this charge, I have brought this small q at this location. Yes or no? Now, now the forces that are acting on this small q is nothing but what? One is external force in this direction and electrical force in this direction. Both are balancing with one another, and the net force on the object is equal to 0. Understood? Okay. So now what I am doing here is I am removing this external force. I am removing this external force. Okay, so now the only force that is experienced by this charge is nothing but what? Is nothing but field force, and the field force is acting in this direction. So only one force is acting on the object, that is nothing but field force, that is acting in this direction. So that means the net force acting on the object in this case is not equal to 0. So whenever the net force acting on the object is not equal to 0, then what will happen? What will happen? This charge is going to accelerate or not? Yes or no? This charge is going to accelerate. Yes or no? So since net force acting on this charge is not equal to 0, then what will happen? This charge is going to accelerate. Understood? So it starts moving away from what? Away from capital Q. Understood? So it is just like I have brought here, I have done some work. Okay, so whatever the work I have done, that will be developed as potential energy. Now the system is having some potential energy. Yes or no? Okay, now what I am doing, I am removing the force. I am removing the force. Then what will happen? Whatever the potential energy you have gained up till here, now it is going to convert into what? It is going to convert into kinetic energy. Yes or no? Now this charge is going to accelerate. Yes or no? Now it is going to gain some velocity. Okay, it is going to accelerate. So its velocity continuously changes here. Its velocity continuously changes until this field force acts on that charge. Understood? Now let us assume this charge has moved far away. Let us assume it tends to infinity. So if it moves to far away, it tends to infinity. So at infinity, the effect of this field force will be what? Will be 0. So that means once this charge moves to infinite distance, then it is not going to experience any force. It is not going to experience any force. Understood? So once it is not experiencing any force means, then from that point what it will do here? It is going to move with the same velocity. Yes or no? So from here, whenever you move the external force, so only one force acting, that is electrical field force. So because of that force, what will happen? This charge is going to gain some velocity. That means it is going to have some acceleration. So until this force acts on this charge, okay, so this velocity is going to change. This velocity is going to change. So now if you move to infinite distance here, so at that infinite distance, the force acting on this charge will become what? Will become almost to 0. Okay, but here this charge is moving or not? This charge is moving. Yes or no? It has gained some velocity and it is moving. So once it reaches to infinity, so at infinity the field force will almost become 0. It almost dies out and it will become 0. Now at this instant it is in motion. Yes or no? So whatever the velocity it has gained at infinity, with that velocity it will try to move with the same velocity forever. Understood? So that means at infinity the force acting on the charge will become almost equal to 0. So that means at infinity whatever the velocity it is having, with that velocity it continues to move forever. Understood? Okay. So is this point clear here? Tell me here. Is this point clear? See, whatever I have explained, is this point clear? Tell me. Let me know here. Let me know, is these points are clear? Tell me. Is this clear here? Alok Kumar, Teja, tell me here. So whenever you remove here external force, only electric field force is acting on that charge. So until the force exists, it is going to accelerate. Yes or no? So this force will exist up to infinity. Once it goes to infinity, this force will almost go to what? Almost go to 0. So at infinity, whatever the velocity it has gained, okay, so with the same velocity it continues to move, because once it reaches to infinity, there the effect of this field force will be 0. So then it continues to move with what? It continues to move with the same velocity. Then after that its velocity is not going to change. Understood? Okay. So that's what I am saying here. So understood here, Alok Kumar, Teja? Okay. Okay here. So now in this case, how I can frame the problem? In this case, how I can frame the problem? See here. See, I can ask you like this. So here you are having a capital Q, a charge here, and I have placed another charge. I have placed another charge, small q, at a distance r. At a distance r. Okay. So initially this charge is at rest. Initially this charge is at rest. So rest means what here? So rest means here what is the force acting on this one? Here the force acting on this one is electrical field force. So another one must be what? Must be external agent. Okay, if only field force is acting, then it cannot be at rest. Okay, if it is at rest means, so one force, field force is acting in this direction and external force is acting in this direction, such that the net force acting on this one is equal to what? Is equal to 0. So this is the first step here. This is the first step. So next what I am doing here is I am removing F external. Okay, so F external is equal to 0. Okay, so that means I am removing or so okay, what I can say here? Okay, you can take F external equal to 0. That means force applied by external agent. Force applied by external agent is equal to 0, or I can say external agent has removed the force. Okay, so there is no force applied by external agent. So now in this case what will happen here? What will happen? So here small capital Q and here small q, and here this is the distance from here to here. Now here the force, only force that is acting on this charge will be what? Will be F electrical. F electrical. Right. So here in this case F external is equal to what? F external is equal to 0. Now in this case what is the net force acting here? Net force acting is nothing but what? Is nothing but only electrical force. So whenever net force acting on the object is only F electrical, so that means if the net force acting on the charge is not equal to 0, then it is going to what? It is going to accelerate. So Fe is equal to what here? Is equal to m into what? M into acceleration. M into acceleration. Now this electrical force is nothing but what? This electrical force is nothing but E into Q. E into Q. Yes or no here? Okay. So this electrical force is nothing but what? Is nothing but E into Q. So that is equal to what? That is equal to M into A. M into A. Right? Okay. So this is the force. This is the okay. Okay, so this is the force it is experiencing. So it is going to have acceleration. So if they ask to determine the acceleration, then you can determine here. You can determine the acceleration. Acceleration is equal to what? EQ by M. So from here you can determine what? You can determine the acceleration. So you can determine E field, and they are going to give you Q value. They are going to give you mass value. From here you can determine the acceleration. So this is one thing they may ask. And second one is so whenever it is accelerating, okay, so here it is accelerating, since net force acting on this one is equal to is not equal to 0. So it is going to accelerate. That means its velocity is going to change. Yes or no? So its velocity is going to change, and it is going to move along this force direction. So up to infinity here. So once at infinity, once it reaches infinity, so then in this case, electrical force acting on the object will also go to what? Will also go to 0. So now in this case, that means infinity means it is not exactly infinity here, approximately infinity. That is very, very far away from this charge, such that we can neglect the force acting on the charge. Understood? So once you reach to that location, now here the force acting on this charge, the net force acting on this charge will be equal to what? Is equal to what? Is equal to 0. The net force acting on this charge will be equal to 0, because already you have removed what? You are not applying any external force, only electrical field force is acting on this object. So until this force is present, it is going to accelerate. That means its velocity is going to change. Yes or no? So now as it reaches to infinite distance, almost at infinite distance, at far away distance, the electrical force will also goes to 0. So now no forces are acting on this charge. Okay, but here to here it has gained some velocity. It has gained some velocity. So whatever the velocity it has gained at infinity, so with the same velocity, so let us assume it has gained a velocity of v here. Let us assume it has gained a velocity of v. So from this point here, from this point, whatever the distance it can move forever here, forever, okay, up to infinite amount of time. So whatever the distance it will travel from this point, it is going to move with what? It is going to move with the same velocity. So whatever the velocity it has gained, whatever the velocity, this is velocity here, I am representing with small v here, velocity. You should not confuse between velocity and potential. Okay, so that's why I will represent this velocity with a small letter, So this is the velocity at infinity. This is the velocity at infinity. Okay, so whatever the velocity that is present at infinity, so with the same velocity it continues to travel, continues to move. Understood? Okay, so now they may ask you determine what is the velocity at infinity. What is the velocity at infinity? So that means they may ask you to determine what? To determine v infinity value. Okay, so now in this case, how you can determine here? V infinity means velocity at infinity. Infinity means it is not exactly infinity here. It is a far away distance from the charge, such that at that distance, we can neglect the force, we can neglect the field force. Understood? Okay. So at that distance, what is the velocity? They may ask. So in this case, how you can determine the velocity here? How you can determine the velocity? See, initially, whenever it is at rest here, initially it is at rest. So whenever it is at rest, it is going to have what? It is going to have only potential energy. It is going to have only potential energy. From where you got this potential energy? Because in order to move this charge from infinity to this point, you have done some work. So whatever the work you have done, that will be stored as potential energy. So whenever you place these two charges separated by a distance r, this system is going to have some potential energy. So that potential energy is nothing but what? Is nothing but QQ by what? QQ by 4 pi epsilon r square. QQ by 4 pi epsilon, not r square here. QQ by 4 pi epsilon r. So this is the potential energy you are going to have initially. Understood? So next what you have done? You have removed the external force. So now once you remove the external force, what will happen here? So whatever the potential energy it has gained here, now what will happen? That potential energy is converting into what? Is going to convert into kinetic energy. Yes or no? Okay, and and when it reaches to infinity, so it is at far away distance, so that means r will tend to what, r will tend to infinity. So at this point the potential energy will almost go to what, almost go to 0. Now it is having only velocity. Understood? That means it is having only what, only kinetic energy, only kinetic energy. So initially it is having only potential energy. Once you remove the external force, then it started accelerating, so until the force acting on the charge. So at infinity the force will almost die out, then whatever the velocity it has gained up to that point, with that velocity it continues to move. So that is the final velocity of the charge. Understood? So if at final velocity of the charge is nothing but v infinity. So at this point it is moving only, it is having what, it is having only velocity. Yes or no? Okay, so the potential energy of the charge is equal to what, at this location the potential energy is equal to what, is equal to 0, because here r tends to what, r tends to infinity. So the potential energy at this location will become 0. So it is having only velocity, that means it is having only kinetic energy. Understood? So from law of conservation of energy, whatever the potential, total potential energy that you are having here, so always the total energy must be what, must be constant with respect to time. Yes or no? From law of conservation of energy, the total energy must remain what, must remain constant. So here the total energy is nothing but what, initial potential energy plus initial kinetic energy. So initial kinetic energy is 0, it is having only initial potential energy. Okay, so that must be equal to what, that must be equal to finally it is having only kinetic energy and potential energy is equal to 0. Understood? So that means you have to equate what, total initial energy must be equal to what, total final energy. So now from here total initial energy is nothing but what, is in the form of I am writing here, yeah, I'll write here. Okay, so I am writing here, so the total energy here, the total energy initial must be equal to what, the total energy final. So this is from what, this is from law of conservation of energy. So now here total energy initial, what is the total energy initial here, is nothing but initial potential energy plus what, initial kinetic energy. So this is equal to what, this is equivalent to, so potential energy final plus what, kinetic energy final. Understood? So initially the system is having only potential energy and kinetic energy is equal to 0. Finally it is having only kinetic energy and potential energy is equal to 0. So therefore I can write initial potential energy is equal to what, is equal to final kinetic energy. So what is the initial potential energy here? So the initial potential energy is nothing but what, q by 4 pi epsilon naught into r. This must be equal to what, final kinetic energy. So that is nothing but what, half into m v square, So v infinity, they don't represent v infinity, all those things here. So in order to understand, for just understanding purpose, I am representing this is the velocity or final velocity. Okay, yeah, final velocity at infinite distance. Okay, so q by 4 pi epsilon naught r is equal to what, half mv square. So now from here you can determine what, you can determine v infinity, yes or no? So this is equal to what here, this is equal to, now here, okay, so now here this capital Q by 4 pi epsilon naught r, capital Q by 4 pi epsilon naught r will represent what, will represent the potential, at r with respect to what, with respect to infinity, yes or no? Okay, so if you substitute all this here, what you are going to get, you are going to get 2 into v r infinity q, right, divided by what, divided by m square root. Okay, just I have replaced q by 4 pi epsilon naught r is the potential due to this point charge at a distance r. So I am replacing that with what? V r infinity. So there is no need to represent every time infinity here. You have to understand that. Just for understanding purpose I am representing every time, right? Okay, so V infinity, this is the final velocity here. This is the final velocity of the charge. Okay. Okay, so this is the final velocity of the charge. So they may ask you to determine what? To determine the final velocity. They may ask you to determine the final velocity. Okay, so in this manner they may frame the questions here. So just try this problem here. So the same problem, just I am giving some values. Okay, so let us take a capital Q is equal to some 20 microcoulomb and small q is equal to 10 microcoulomb. Let us consider capital Q is equal to 20 microcoulomb and small q is equal to what? Small q is equal to 10 microcoulomb. So initially these are placed like this here. Initially these two charges are placed like this at a distance. At a distance, let us say the distance between these two is 2 meters. Let us assume the distance between these two is 2 meters. Okay, okay. Now here the forces acting on this one is F external and here the force acting is F electrical. Okay, so next if and and you can write a mass of Q is m is equal to some 9 into 10 to the power of minus 16 kg. So I have given mass here. Mass of this charge Q is m is equal to 9 into 10 to the power of minus 16 kg, right? Now if F external is equal to 0, if F external is equal to 0 or F external is removed, or if F external is removed, then determine the velocity, of Q at infinity. So that means at very, very far away distance. Okay, so do it here, do it and tell me the answer. Do it and tell me the answer. Do it and tell me the answer here. Tell me. How to determine? So initially it is having what? It is having only potential energy. Yes or no? So initially it is having only potential energy, right? So once external force is removed, then this charge will move. Charge will move in the direction of what? In the direction of electrical force. So at infinity it is going to gain what? It is going to have some constant velocity. Yes or no? So at infinity okay, so the charge is going to have what? The charge is going to have only kinetic energy, So initially it is going to have only potential energy. So here the total energy, so the total energy initially is in the form of what? Is in the form of only potential energy, because here the velocity of the charge is equal to 0. So initially it is having only potential energy. So once external force is removed, then it is going to move away from this charge. Understood? So once it reaches to infinity, so at infinity the force acting on the charge will be approximately goes to what? Approximately goes to 0. So if the charge, if the force is not acting, means it is going to continue with what? It is going to continue with the constant velocity. So that means whatever the velocity it has gained up to infinity, with that velocity it continues to move. Understood? Now you have to determine that velocity, final velocity, or the velocity at infinity. So at infinity distance it is going to have only kinetic energy. Okay, so the total final energy is in the form of what? Is in the form of kinetic energy. Okay, so now you have to just equate the potential energy initial is equal to what? Kinetic energy final. Okay, so this is nothing but what? Total energy initially, and this is nothing but what? This is nothing but total energy finally. So total final energy is in the form of kinetic energy, total initial energy is in the form of potential energy. So from law of conservation of energy, the total initial energy must be equal to what? Total final energy. So now equate this to what you are going to get. So this is nothing but what? This is nothing but potential energy initially. So what is the potential energy initially? You are going to have q by 4 pi epsilon naught into r. Yes or no? This is the initial potential energy. So final kinetic energy is nothing but half into mv square. Okay. Now therefore we, so just substitute these values here. Okay. So capital Q I have given as what? I have given as 20 microcoulomb. Small q I have given as 10 microcoulomb, and 1 by 4 pi epsilon naught value is 9 into 10 power 9. Okay, so this is 1 by 4 pi epsilon naught value. So divided by what? Divided by r value I have given as 2 meters. So this is equal to half into mass I have given as 9 into 10 to the power of minus 16 kg into V infinity square. Okay, so just do these calculations here. So here 2 will get cancelled, and here 9 and here 9 will get cancelled, right? So what you are going to get? 20 into 10 into 10 power minus 12 into 10 power 9. Okay, so if I send this 10 power minus 16 to this side, you are going to get 10 power plus 16. So this is V infinity square. Okay, so if you want V infinity is equal to what? Is equal to square root of what? Square root of 200 into, so here you are having 10 power minus 12 and here 10 power 9, here 10. Okay, so do this here, 10 here, do this calculation here. 20 into 10, 200. So 10 power minus 12, 10 power 9 is 10 power minus 3 into 10 power 16, 10 power 16. Okay, so that is equal to square root of, I can write 2 into, so 10 square into 10 power minus 3, 10 power minus 1 into 10 power 16. So I can write 10 power 15. Yes or no? Okay. So V infinity is equal to square root of 2 into 10 to the power of 15 meter per what? Meter per second. Okay. Okay, yeah. Have you understood here this problem? Tell me. Is it clear? Tell me how to determine the final velocity. Tell me here, Alok Kumar, Teja. Is it clear? Yes? Okay, yeah. So I hope this problem is crystal clear. Okay, so try this problem here. I am giving this problem as homework. Okay, try this one here. It appears to be tough, but it is not tough. If you have understood the concepts clearly, then you can easily solve the problem here. So try to do this problem as homework. At least try here. Try this one. See, in the previous problem I have given some charge, capital Q, but here I have given some charge distribution. That's it. So the charge distribution on this semicircular ring. Okay. Okay. So I have given this problem here. Try to do this problem as homework. Okay, so a semicircular ring with radius capital R equal to 4 meters carries total charge Q is equal to 10 microcoulomb that is uniformly distributed over the ring. If a positive charge Q is equal to 1 microcoulomb with mass M is equal to 9 into 10 to the power of minus 15 kg and release from still. Release from still means what here? Release from still means released from rest. Released from rest. So that means initially this charge is at rest. Okay, so then what they have done, they have removed, they have released this charge, means they have removed the external force. Understood? So once they have removed the external force, what will happen here? It is going to accelerate. Yes or no? Because some field force, due to this charge distribution, some field force is going to act on this charge. Understood? Okay, so only the field force is acting on this charge, then what will happen? It is going to accelerate. Understood? Okay. Okay, yeah. So still means it is at rest, at point O, at point O. It will be pushed away to infinity. It will be pushed away to infinity. Why it is pushed away to infinity here? Because of this field force exerting on that Q. Understood? Okay. Okay, so then you have to calculate what? You have to calculate the final velocity at infinity. So that means they are asking to determine what? They are asking to determine V infinity. Right? Okay, so they have given some charge distribution, some semicircular ring. Okay, so here at the origin they have placed a charge. Understood? Now now initially it is at rest, so that means initially it is having only potential energy. Yes or no? Next, what they have done, they have released this charge. So once they have released this charge, what will happen? It is going to accelerate, because the only force that is acting on that charge is going to be field force. So because of that field force, what it is going to happen? It is going to accelerate from that location. Understood? So it is going to accelerate, and at final, that means once it reaches to infinity, there the field force will almost dies out. That means it will become 0. Then it is going to have some constant velocity. Now they are asking that constant velocity here. That's it. Okay. Okay, so try this problem here, try this problem. We have already determined here, the potential due to a uniformly charged circular ring. Yes or no? Here they have given what? Only semicircular ring. Understood? So that means the potential at this location must be what? Must be half of what? Half of the potential of the circular ring. Yes or no? Okay. You can easily calculate that potential here. I have already told, right? Okay. So try this problem here, try this problem as homework, right? Okay. So if you do this one and give me the answer tomorrow, it is very good, and it is excellent here. Okay. So I hope at least any one of you persons will give the answer. I hope so. Okay. Whether it is correct or wrong, it doesn't matter. If you try and if you give the answer to this question, okay, so that is going to be excellent, right? Okay. Okay, yeah. So with this, I am winding up the session for today. So tomorrow exactly at 4 p.m. Tomorrow also exactly at 4 p.m. we are going to start the session on EMT. Okay. So if possible, so we'll try to solve some 1 or 2 problems here based on this concept, right? So once we complete that, if possible, I'll start some new topic, right? Okay. So tomorrow exactly at 4 p.m. here. So I hope everything is crystal clear up till now. Okay. So with this, I am winding up the session. So tomorrow we will meet at the same time here. Okay. So until then, take care. Bye bye.